we already did 2 examples on proving identities. So let us look at this number right now. So again, looking at both the left hand side and the right hand side, I think it is reasonable to start like thinking that we should work with the left hand side because there's more terms in the left hand side and there's more room for simplification on the left hand side rather than just using the right hand side. Okay, so we figure out, we decide first which side we want to work with. Again, the left hand side. I think most of the times you will see in this proving identity section that we like to start with the left hand side. Okay, so we'll start with the left hand side and then we'll see what we can do, how we can simplify that and in a way make it look like the right hand side. Okay, so let's start with the left hand side again, as we have been doing in other examples. What I'm going to do is, well, sine x plus cosine x. There's no room, there's not really so much room for like simplification with that piece, but the downstairs one, I mean, one can still simplify this and or write this in terms of the cosecant and secant. Yeah, well, you can do that. Guys, as I said, like there's more than one ways to actually do like proving these identities or even like doing anything in mathematics in general. But you have to finally decide to choose one method and then work with that one. So I'm leaving the numerator like that. Rather, what I'm going to do is I'm going to try to like simplify or do something with the denominator. And when I say simplify, what I'm basically going to do is, I mean, I don't have too many options. There's only like one thing that I can probably do here, which is I can rewrite the secant and cosecant in terms of the cosine and sine, because we know that the cosine is the reciprocal of secant and sine is the reciprocal of the cosecant, right? So I can write this secant as 1 over cosine x, and then I can write this cosecant as 1 over sine x. Right, so that's the first step. Now again, numerator, we're not doing anything really with it, so just let us still leave it like that. And even like just by watching my previous videos, what we have been doing with the fractions, like one we have here, we like to combine them, right? We want to combine the fractions. To combine fractions, we have to have a common denominator, right? That's a key concept in combining fractions, whether you are working with just numbers, whether you're working with variables, in this case, whether you're working with the trig functions, the idea is still the same. To combine, you got to have a common denominator and then only we can combine the numerators. So in this case, what we can do here is like they have a different denominator. So I can multiply this guy by cosine x, right? And I can multiply this guy by sine x to get a common denominator. But if I multiply this by cosine x downstairs, we got to multiply upstairs by cosine x as well. We already know that. Same thing here, guys. I multiplied this by sine x, so I have to multiply upstairs by sine x as well. Just creating common denominator and doing what we need to do in order to combine the numerators. Okay, so from here I'm going to write the numerator as it is. In the denominator I have, what do I have? I have sine x plus cosine x. I'm already combining them because I have the same denominator, so there's no need to write an extra step. And then downstairs I have sine x times cosine x. Guys, again, here I have sine x times cosine x. Same thing, sine x times cosine x. So I just have to write it once and I can simply combine the this sine x and this cosine x. Now let us see what we can go, where we can go from here. Guys, from here, what we can do is we can just still simply write sine x plus cosine x, which is the numerator, divided by, now this division, I'm going to change it to a multiplication. Sorry about this. So I'm going to, let's put it in the parentheses, times. So when you change this big division into multiplication, you already know what's going to happen with these. These are going to like switch, right? These are going to reciprocate when you multiply, when you change this division to multiplication. So it's going to look like this, times sine x cosine x divided by, and let me put that in parentheses as well, sine x plus cosine x. Guys, there was a division here. You can see this division here. I mean, if you want me to make it bigger, I can make it bigger. And then this ratio here, when we change this to a multiplication, we know that the ratio is going to reciprocate. That's exactly what we did and what we wrote here. We know there's an invisible 1 here. We don't really have to write it, but we know there's an invisible 1. Guys, this term and this term, they exactly are the same terms. What will happen to them? They will simply cross out. It's like a quantity divided by itself, just crosses out, or it just gives you a 1. Then 1 times this is simply sine x, cosine x. But that's not what we want this to look like. Well, we have a sine x, that's good news. But then we want it like, we want in the denominator, we want a secant x. But that's not too difficult to get because we know that, let us keep that sine x because there is a sine x here on the right hand side. And that's what I have been trying to tell you in my previous videos as well. Once you get to a very simplified form, then we stop there, we look at the right hand side, and then from there we figure out which identity I should use. In this case, I see there's already a sine x here, there's a sine x here in the numerator, so I'm not going to touch the sine x here, I'm just going to leave it like that. But then I have a cosine x multiplied, but there's the secant x dividing sine x. So what I can do is, I know that the cosine x is the reciprocal of the secant x, so I can write the cosine x as 1 over secant x. And then if I combine these things and like multiply them, it will become sine x times 1, which is sine x, divided by secant x. That is how exactly my right hand side looks like, which implies that the left hand side equals to the right hand side, and we are done. Guys, this was example number 3, type 3. I have decided to do 7 examples in this section. I will start by doing 7, and then we'll see maybe if we need to do more different types, because there is so many different types in this section. I can go up to 10 examples, but so far we have learned 3. Guys, please practice more of these types or different types, like even some things that we may have not yet covered. You can still try them on your own, and then I will try to cover other types as well. Okay, guys, till then, take care. I will see you with example 4 in the next video.